This is a status report of the Fox project, a DOE XStack program, on our new Kittyhawk failure testbed. The current BlueGene P failure model is based around full system checkpoint restart. Guarantees about high-performance interconnect packet delivery create a situation where the death of a single node effectively brings down the entire machine. This makes it difficult to test and evaluate fault-oblivious system software, runtimes, and applications on BlueGene P, as the underlying interconnect hardware and production system software is not tolerant of node failure. For the Fox project, in order for us to be able to evaluate the fault tolerance of higher levels of the stack, we must first correct this problem in the system software and infrastructure. Here we see a visualization of the Kittyhawk web interface. The web interface allows us to select the number of nodes for a user's application to be deployed upon. The blue nodes are administrative nodes, green nodes are the user's application, red nodes are failed nodes, and yellow nodes are nodes that are no longer reachable because of failure. So we've allocated the full block to the user's application, and now we'll show you what happens when you kill a single node in the legacy software. As you can see, the entire system shows as being failed because all nodes are now unreachable from the outside world due to the nature of the BlueGene infrastructure and production system software. So, our solution, is to use the Kittyhawk alternative infrastructure for BlueGene, which allows us to replace the production system software with a custom system software stack which has better reliability properties, including the ability to survive certain types of node failures. By using Kittyhawk and adding an API for injecting faults which disable nodes on a BlueGene P, we create a failure injection testbed to evaluate fault-oblivious and fault-resilient runtimes and other layers of the software stack on leadership hardware at scale. So here we see the same visualization with the nodes pre-allocated, but we're running our upgraded software infrastructure. And what I'm going to do is I'm going to kill a node at random, and you'll see that one node dies and two nodes are unreachable, but the rest of the system is still running the application and reachable. For both of these, we're using an MPI ping pong application. I'm going to kill a couple more nodes at random, and you'll see that some nodes that are at the leaves only affect themselves and do not create any more unreachable nodes. While if I kill nodes that are closer to the lower numbered ranks, it affects more nodes. So killing a node in one of the low-level ranks can take out a whole column, or even most of the block becomes suddenly unreachable for reasons I'll explain in just a moment. This is the problem with so many unreachable nodes happens because of OpenMPI cascading failure. By default, OpenMPI and some other MPI variants use binomial tree distribution for efficient broadcasting collectives. Failure at leaf nodes only affects the leaf nodes. Failure closer to the core of the tree affect all the children of that node. So the higher up the failure happens, the more nodes are affected. This is particular to the problem with MPI. Next steps are that we're going to now port other components of the Fox project to run on top of this failure testbed, starting most likely with the TESL runtime framework. We're going to rework the Kittyhawk infrastructure so that it can be used at larger scale. Currently it operates at up to 4 racks of BGP. We're going to explore methods to reboot and recover failed nodes without a full system restart. And as the hardware becomes available, we will be porting the Kittyhawk and failure testbed to BGQ. Thank you.